We're here with Paul Brubaker. Paul is Administrator of the U.S. Department of Transportation's Research and Innovative Technology Administration. Long title, and it's got technology and innovation in it. Give us some background on the U.S. DOT's RITA, I guess is how you refer to it.
Yeah, RITA is what we prefer to call that. Yeah, because it is an awfully long title. I almost need 2 business cards to squeeze everything in. Yeah, RITA is a relatively new creation. We were created in 2004 from a piece of legislation known as the Mineta Act, which really sought to coordinate and consolidate the research investment across all the various modes: Federal Aviation Administration, Federal Highway Administration, 2 of the most familiar modes. But we were created specifically to coordinate the research investment across those modes and then focus on multimodal research. And RITA is a combination of a number of different organizations which at one time were independent or part of another organization, like the Volpe National Transportation Center, which is the transportation center for the department, which really does a lot of sort of cutting-edge research around and policy research around problems that face the department now.
So when you talk about transportation, it's not just automobiles, it's much more than that.
Oh no, it's we like to refer to it as, planes, trains, automobiles, and ships.
Okay.
And ships are sort of short sea shipping, and the Maritime Administration is an integral part of the department. So we want to make sure we don't ignore the needs of the shipping community. But as well, we look at rail and aviation and the roads and the trucks and really want to understand the performance of the passenger and freight movement systems holistically, and how they operate with multiple modes.
In this day and age, it seems to me that transportation is at the top of, or near the top of, just about everyone's list in terms of important issues, important challenges that affect so many other industries.
Oh, absolutely.
What you're doing is really critical.
Yeah, it's what we call a diagonal industry, because if you think about it, I mean, transportation touches everything we consume. From groceries to, the electronics that we buy. But we also use transportation as consumers. We buy automobiles, we buy GPS devices, we buy car stereos, rims, wheels, tires, you name it. I mean, there's a lot of things that get consumed at the vehicle level. And it might surprise you to know that actually transportation, according to the Bureau of Transportation Statistics, which is another RITA agency, I might add, it calculates that transportation expenses are the second highest expense for a household, right behind housing. It's housing, transportation. We actually spend more money as individuals on transportation, our transportation needs, than we do on food or health care.
Well, as we fill up at the gas pumps these days, that point is certainly
more and more
been brought
evident.
home.
Yeah, it's becoming an increasingly larger slice of that pie in terms of household expense.
And so your mission then is to look at technology and how that can impact transportation to make it, I assume, more affordable, more effective, efficient, et cetera.
That's exactly right. I mean, we look at our research portfolio, and what we try to do is structure research in such a way that will improve safety in a measurable way, as well as improve mobility. And we're looking at some technologies that will enable us to basically improve the performance of the existing infrastructure by keeping traffic flowing, reducing congestion, and there are technologies that we believe will enable that.
And I'll bet even since 2004, when RITA was created, those technologies have changed significantly.
Yeah, they actually have. I mean, there's been a lot of interesting developments in the technology field. I mean, there's something called Moore's Law, named after Gordon Moore, former chairman of Intel, that kind of drives the development of technology. And it basically says that computing capacity will double every 18 months and the price will be reduced in half. So if you think about that in sort of dramatic terms, it's really profound, the impact that technology's had on everything that we do, and including the transportation sector. So it's pretty exciting.
Paul Brubaker. Paul is Administrator of the U.S. Department of Transportation's Research and Innovative Technology Administration, or RITA. I know that nanotechnology, which is a science that is impacting so many industries, is also finding its way into transportation and creating some real exciting opportunities.
Well, that's exactly right. And nano is what brings us here to Albany, and And we view nanotechnology and nanoscale engineering as a game changer, not just for transportation, but for all sectors of the economy. If you think in terms of the advances we're seeing and beginning to see in even the world of consumer electronics, shrinking form factors, incredible capability being pressed into smaller and smaller forms, and we translate that in the transportation sector, and we look at what's happening with our GPS devices or with our electronics that we install in the car, or the electronics that the car manufacturers are integrating into the vehicles. You can just see, sort of this profound wave building in terms of capability that's going to be introduced into the transportation sector. I'm looking at opportunities based on research that's being done here at the Nano Center in Albany to integrate technologies that really haven't been integrated yet in the vehicle. Things like the ability to, you guys have Easy Pass here in New York, but things like the ability to be able to do tolling integrated with GPS, integrated with some safety applications, and getting real-time situational awareness on, in the vehicle to the user, to the commuter, if you will, so that they can do things like make modal choices, decide they're going to take the rail because they know that there's a big traffic jam on I-87. I mean, this is very valuable stuff that will actually improve the commuting experience for the public, also speed the supply chain, because you're not going to have trucks sitting in traffic as much as you have in the past, but also help reduce greenhouse gases and greenhouse gas emissions, because transportation, when it's moving, emits less greenhouse gases than if we're stuck in a traffic jam. So it's a quality of life issue, it's an efficiency issue, it's an environmental issue, and we see these technologies coming together in such a way to really improve that commute and really improve the performance of the supply chain.
And are there some of those technologies that are more say near term than others? I know GPS is something we're all familiar with. Are there others that, as you look to integrate?
Yes, as we're paying a lot of attention to the sensor technology that's being developed here, and as the sensors shrink, as they become more and more powerful, I think they'll be more and more ubiquitous in the infrastructure, whether it's bridges. We can coat bridges with nanomaterials that's embedded in paint or other coatings. Same thing with vehicles. I mean, vehicles can be painted with nanomaterial, and they will have sensors embedded in this material, which will enable us to improve situational awareness. Essentially, and the end state will be, in my view, and it's sort of a vision that I think is supported by the technology and the research that's being done, but I think we'll be able to manufacture vehicles that don't leave the road, number one, and number two, don't crash into one another, which is a huge economic impact. If you think about it, we have 6 million crashes every year in the United States, lose 42,000 people. Economic cost, according to the National Highway Traffic Safety Administration, was about $260 billion based on a 2000 study, and that's for medical bills and insurance payments and car repair and all the economic costs of the pain and suffering that people have when they're in accidents. If we can eliminate accidents, think of the economic savings, think of the savings in lives, think of the savings in injuries and pain and suffering of individuals, and I think nanomaterials will enable that.
And as you mentioned, economic, safety, there are so many implications that are so important.
Yeah, it's critical.
Back with Paul Brubaker. Paul is administrator of the U.S. DOT's Research and Innovative Technology Administration, or RITA. You've had an opportunity to see the facility here at the Nano College, to not only see it, but begin to understand some of the capabilities. And I wonder if down the road there may be opportunities to share, to collaborate, to really work together on some of the issues you've talked about.
Well, we are very interested in a knowledge sharing arrangement with the center here, and we're watching with great interest the agreement that was just signed between the Army Research Lab and the Nano Center, and think that holds great promise in terms of the technological development that the center is doing for the Army. We want to be able to leverage that to the extent we can, and we're very, very interested in keeping our finger on the pulse and staying close to the center, and sharing knowledge with the center, making sure they understand what our requirements are and what our needs are, and then figuring out how they can contribute from a knowledge standpoint to furthering our objectives, our measurable objectives in the area of safety, mobility, even materials. I mean, we're excited about the prospect of material development that would allow us to build, highways and bridges that would last for hundreds of years as opposed to, 70 or 80 years, with a significantly reduced life cycle cost. Using nano-based composite material and things like that.
We've talked about some of the short-term or more near-term applications. As you look out far into the future, it's always fun to think what may be down the horizon, whether it's 15, 20 years down the road. And I wonder if there are some of those applications that you're at least looking at this point and saying, gee, is that a direction we should move in? And if so, how?
Oh, absolutely. I mean, we're looking at a couple of things, really. One is basically nano coatings for roads. I mean, road surfaces. You could basically, the vision is that you could basically be able to paint the surface of a road, and we know that there are a significant number of car crashes that are a result of road departure. You could actually coat the road and then build sensors into the vehicle that could communicate with the road so that the car basically wouldn't be allowed, the vehicle wouldn't be allowed to leave the road, essentially, unless you disabled it so that you could pull off, say you had a blowout or something like that. But hopefully, looking 20 years down the road, I'm assuming that there will be some development in the nano arena that will allow for tires, to be, non-flat tires, which would just be, revolutionary. I mean, nanotechnology is an absolute game changer. I'm not sure the American public quite realizes it yet, but they will soon enough when they start seeing the advances and things they use on a daily basis and the significant improvement in quality of life. And I think it's just a really exciting time to be in this area, or at least I'm tangentially associated with it. I can't certainly take any credit for it, but it's fun to watch what's going on here and then use your imagination and see where we're going to be in 20 years. And you could easily see in 20 years a vehicle, thanks to nanotechnology, that is a hydrogen plug-in electric hybrid vehicle that has that's coated with colored photovoltaic cells that power the electronics on the vehicle. And I don't think that's a pipe dream. I don't think that's it may be 20 years away or 30 years away when it's ubiquitous, but I think that's something that we can do in almost the foreseeable future. I would say probably next 5 to 10 years. That's very conceivable, and it's based on and enabled by the technology that's being developed right here in Albany, and I think it's very exciting.
You use the word exciting, and I think when most people think transportation, they don't think of it as the most exciting field.
Yeah,
but you're
they
clearly
think laying
passionate.
down asphalt. That's what people think of. Yeah, but it's so much more than that, and the changes that are going to occur that will enable us to build roads and bridges that last. And that we can monitor real time, in terms of the health and well-being, and be able to predict, when bridges are going to or could potentially be compromised, and the measurable reductions in crashes and the measurable improvements in mobility and reduced congestion are all going to be enabled by these nanoscale technologies and this nanoscale engineering. It is exciting. I mean, I'm sorry, but I love this stuff. I think it's great.